Hello, so today I'm going to be explaining number 51 from the homework problem. So basically, for the sake of just making this easier to follow, I'm going to be referring to the equation given as, hang on, f of x. So f of x equals x times 3x squared plus 1 all to the ninth. And basically, it asks us for the third derivative set to 0. That might be hard to see, but okay. Hopefully that's a little bit better to see, because I'm likely going to use the entire sheet, so I don't think I can crop it, although I probably won't know until the editing if I can actually crop it to make it easier to see, but anyway, so the first derivative, we take the product rule, alright? So to make this easier to follow, we're going to say this x term is red, and this what obnoxious term is green. I don't know what else to call it, but anyway, so the product rule states that so basically we have, so for f prime of x, we have x times the derivative of 3x squared plus 1 to the ninth plus our derivative of x times the other term just left alone. So from there, we have to take multiple derivatives. I will actually hold it up to make it easier. Okay, that doesn't help much. But hopefully that's a little bit better to see. Because I just moved my computer with my phone up a bit. So hopefully that's easier to see. So then from there, that would be equal to basically keep our x as is, and then the derivative of this, we take the chain rule, which I'm actually going to split that up. So that would be, so the chain rule states that we take the derivative, like basically ignoring the inside. So that would be 3x squared plus 1 to the 8th power. I kind of wrote this wrong, but it's still times 9. I almost forgot about that part. And then we multiply that by the derivative of 3x squared plus 1. Hang on, I'm trying to make that as easy to see as possible. And then our derivative of x is just going to be the number 1, which if you multiply 1 by anything, you just get whatever it's being multiplied by. So we're just left on this part with 3x squared plus 1 to the 9th. So from there, that means, so we're just going to simplify this just to make it easier on us for taking future derivatives. So that means, so up front, we then have 9x times 3x squared plus 1 to the 8th. And then times our derivative of this, which, that's the wrong color, whoops. But anyway, so that's, so our power rule says basically that our derivative of this, we just have, so 2 times 3, 6, and then we lose one exponent value, and then the derivative of 1 is just 0, since it's just like a flat line slope. And then plus, basically this all over again. And I'm actually going to write this, even though it's to the 9th power, I'm actually going to write this as the 8 plus 1 power, which, just to make it easier to see what I'm about to do next. So next, we can see that both terms have a have this term here with 3x squared plus 1 all to the 8th. So now, since we have that present, we can basically just factor that term out. So basically, we are left with 3x squared plus 1 to the 8th, right? And then we just multiply our 6 from there. We just have these two terms. So then it's just 9x times 6x, which gives us 54x squared plus, and then we just basically have 3x squared plus 1, since basically our exponent of 1 makes it so that we just have the terms by themselves. We don't really have an exponent anymore, but at the same time it's not equal to 1, since the exponent is not equal to 0. So from there, we can rewrite it as 3x squared plus 1 to the 8th, multiplied by 57x squared plus 1. Right? So we're just simplifying it at that point. So that would be our first derivative, all simplified down. So that basically we no longer, just to make our lives easier for taking the second derivative. So for our second derivative of x, we have to do the product rule again. And y'all can't actually see that, okay. Okay, there we go. Hopefully that's a better angle. Also, guys, sorry if my arm is getting in the way. I'm kind of doing this tutorial while standing, just due to like the angling and such. But anyway, so actually this might be a better angle for me to write from. Yeah, because now I can actually see the footage and still write. Although, okay. So f double prime of x, so we still have to do the product rule again. So this will be our first term, and this is our second term. Okay, so now we have 3x squared plus 1 to the 8th times derivative of 57x squared plus 1 plus and then I'm just going to write the rest down here because I am definitely going to run out of room on this line. So then we add derivative. If you have like less large handwriting, this will probably work fine, but I have large handwriting, so it kind of is what it is. So derivative of our first term times our second term just left alone. So from there, we basically just have to take the derivatives of these two terms, like those two portions of the terms. So we have all that is equal to, actually I'm just going to use pencil for the rest because I basically just visualize all that for you. So 3x squared plus 1 to the 8th times, so our derivative of this term, so that would be equal to, so 57 times 2, since the derivative of 1 is just 0. So that would be actually 114x would be our derivative. Plus our derivative of this term, which I actually will color code. So our derivative of that term would actually be 3. So 8 times 3x squared plus 1 all to the 7th power. That's our first part of the derivative. And then our second part of the derivative is going to be derivative of 3x squared plus 1 multiplied by 57x squared plus 1. My handwriting is kind of trash, and I'm sorry, especially towards that end right there. So from there, we can actually just take our 114 x and turn it into a coefficient just by rewriting it over there. So this part we just leave alone, basically. Actually, I'm going to write this 8 exponent as 7 plus 1 exponent. So that will become important later. So from there, we leave this part alone. And then from there, we already established that the derivative of 3x of this part is 6x. And then it's just 57x squared plus 1. So now, you'll notice that we have this term, the 3x squared plus 1 to the 7th part in both terms. So that means we can actually move that to the outside. So 3x squared plus 1 to the 7th plus, okay, that looks like an x. That's not what I meant. That's supposed to be a plus sign. Wait, no. Why did I even write a plus sign in the first place? So 114x plus, so we can multiply these two, which will give us 42x times 57x squared plus 1. Okay. And then from there, we basically just simplify the rest. So we leave this term alone. And this part also gets left alone for now. So we can actually so probably our best bet to simplify is to basically bring it sounds a bit counterintuitive, but at this point we want to bring the coefficient to the inside so that we can combine like terms. So at that point it would be 42 times 57. Okay, so that would give us 2,394. X to the third, actually. Yeah, I am on the right track. Plus 48x. Sorry if I keep pausing, I'm just cross-checking with the work that I already did, just to make sure that I'm on the right track. So I basically have my work on the side. Oh yeah, I can't forget the closed parentheses. And so then from there, we can basically just add the terms in here. 3x squared plus 1 to the 7th equals 2,394. 4 x the third plus 162x. Which, interestingly enough, the 2,394 is actually a multiple of 162. So we can actually pull out a 162x. Okay, so then we have times 3x squared plus 1 times, that'll actually give us 19x squared plus 1. Oop. Okay, phone, you really don't need to fall on me. Well, it's not literally falling on me, but I think you get what I mean. So, I'm actually sharpening my pencil, and okay. So from there, we have multiple. If we want to take triple prime, the third derivative, we have two different product rules. What I like to do is I like to separate the terms out as this being, I like to split it with that being one term and this being another term. And I almost forgot that this is meant to be to the 7th power. Okay, so this is meant to be to the 7th power. So from there, we're actually going to first do the power rule on this to calculate the derivative of the red part before we actually take the third derivative. That is the easiest way to basically do it. So now we have d over the derivative of 162x times 3x squared plus 1/7 to the 7th power. So from there, we have our two terms as this one being the first and this one being the second. Right. So from there, we basically have that would be equal to 162x times derivative of 3x squared plus 1 to the 7th plus the derivative of 162x times 3x squared plus 1 all the 7th. Okay, so now from there, we basically just take the derivatives of that. So that's equal to, and 162x times, I'm actually going to split this derivative up again. So that will be 7x squared. Wait, no, it's just 7 times 3x squared plus 1 to the 6th times the derivative of 3x squared plus 1. Okay, and then from there, we have the derivative of 162x is 162, since it's a linear function, and then it's just times 3x squared plus 1 all the 7th. And actually, since we have 162 and 162 on both plus sign, like both terms, we can actually take that out as 162 and then times the rest of this. So from there, we have our x, and then it's 7 times 3x squared plus 1 to the 6th. Just leave that part alone. That is meant to be a 6, not a squiggly line. Times our derivative, which of course we've established is 6x of that, plus 3x squared plus 1 to the 7th, and then that's the rest of our, so I didn't put enough parentheses signs, so that's just that one goes to that one. Okay, so there's supposed to be another end parentheses right there, so sorry about that. So from there, we can then simplify our derivative of those two as 42x squared times 3x squared plus 1/6 plus 3x squared plus 1 to the 6th plus 1, which then allows us to take out as 162 times 3x squared plus 1 to the 6th times 42x squared plus 3x squared plus 1, which really, the 42x squared plus 3x is really just 45x squared. And then from there, we have our derivative of basically those two parts of the equation of the derivative of the second derivative. So from there, we can actually take f triple prime of x, which is going to be equal to so basically our red portion, so 162x times 3x squared plus 1 to the 7th times the derivative of 19x squared plus 1 . Almost forgot to write that it's the derivative. The derivative of that plus, and then we're basically going off the color coding from here when we took the second derivative. Derivative of the red portion that we just calculated of 162x times 3x squared plus 1 to the 7th times our green term just left alone. So from there, we actually have, so we just leave our red term alone. And then it's, so our derivative of this would be 19 times 2, which is 38, minus 1 exponent level of this, and then the derivative of 1 is just 0 again, plus this derivative that we just calculated up here to be 162 times 3x squared plus 1 to the 6th times 45x squared plus 1. And then just multiplied by our 19x squared plus 1. So from there, it looks like a lot, but we can actually take the 162 coefficient out of both terms. So it's equal to, and then we can also take, if we look at this as 6 plus 1 power, we can also take this term right out again. So we then are left with 162 times 3x squared plus 1 to the 6th. So x times 38x is 38x squared plus 45x squared plus 1 times 19x squared plus 1. And then I'm just gonna start this on a new page. So from there, we have we can multiply out 45x squared plus 1 times 19x squared plus 1. Which from there, we have 45 times 19 is equal to 855x to the fourth plus 45x squared plus 19x squared plus 1, which that's basically equal to 855x to the fourth plus 64x squared plus 1. So then from there, f triple prime of x, resuming from our previous, is equal to 162 times 3x squared plus 1 to the sixth times 38x squared plus 855x to the fourth plus 64x squared plus 1. Okay, for a second there I thought I did something wrong on my end, because I was looking at the wrong portion of what I already did earlier. Okay, so which from there we can just this part gets left alone. And then we combine like terms in this section of the parentheses, which leaves us with 855x to the fourth plus 102 x squared plus 1. And I actually okay, there we go, because I thought somehow when I originally did this, I somehow got 105 instead of 102. So that's why I was a bit weirded out. Okay. So from there, we can finally take f triple prime of 0, which is basically the whole point of doing all this shenanigans, was basically so we could plug 0 into all this bullshit, which leaves us with 162 times 3 to the 0 squared plus 1 to the sixth times 855 times 0 to the fourth plus 102 times 0 squared plus 1. And as you guys know, if you multiply anything by 0, you get 0. So all this just comes down to 162 times 0 plus 1 to the sixth times 0 plus 0 plus 1, which all that comes down to 162 times 1 to the sixth times 1, which 1 to any power is just equal to 1. And if you multiply anything by 1, it's just the original number or whatever. So you just get 162 as your final answer. We did Hang on, let me actually pick up my phone to show you guys how absurd this is. We just did 1.5 pages worth of work just to get 162. Wait, that's a 2, not a 7. But anyway, as I said before, this is the most absurd math problem. One of the most absurd math problems I've ever seen. 1.5 pages of work just get 162. For fuck's sake. Why? I just want to know why. I wish I knew why. Anyway, that's how you solve number 51. Hope you guys enjoyed.